Welcome to part 2 of our discussion of subatomic particles. In the last video, we talked about the 3 key subatomic particles, protons, neutrons, and electrons, and some of their key properties that you need to be aware of. In this one, we're going to talk about how do changing the number of each one of those affect atoms and the different forms of atoms we get as a result, and ways that we represent the number of protons, neutrons, and electrons. So to begin, let's talk about atoms, isotopes, and ions. So atoms, as you know, are the simplest form of elements, the smallest you can break down an element. But then you have different forms of certain atoms for each element. You can have isotopes. Isotopes are atoms with identical atomic numbers but different mass numbers. In other words, since they're the same element, they're going to have the same number of protons, but since their mass numbers are different, they must have a different number of neutrons. Let's take a look at an example of this. We have here a series of different isotopes of carbon, and we have written with each one their mass number. So we have carbon 11, carbon 12, carbon 13, carbon 14. If you look at all of the carbons, they all have 6 protons, because by definition, all carbon atoms have 6 protons. So the 11 is the sum of the 6 protons and the 5 neutrons. And the mass numbers are all different simply because they have different number of neutrons, since the number of protons still stay the same. So isotopes have the same number of protons, but they have different number of neutrons. And as a result, they have different mass numbers. Now let's talk about what happens when we have different number of electrons. If electrons are removed from or added to an atom, a charged particle called an ion is formed. So we've been talking about how generally the electrons are the same number as the protons, so you get no charge. But if you add or take away electrons, then you get an ion. So here's a chart with 2 different types of ions. We have ions for oxygen and an ion for nitrogen. In both cases, the number of protons stays the same, because remember, if you change the number of protons, you're going to change what elements you have. So we're only focusing on the number of electrons. In this case, the neutral oxygen has 8 electrons, the same as the number of protons, so 8 positives and 8 negatives cancel each other out. But this oxygen ion has 2 more electrons than protons. And since electrons are negative and protons are positive, you end up with a 2 negative charge. If you look with the nitrogen, you have a similar situation. Neutral nitrogen has 7 protons and 7 electrons. And the ion of nitrogen has 10 electrons and only 7 protons, so you have a difference of 3 more negatives than positives, so you get a negative 3 charge. Now we can represent all this information in an easy to read format called nuclear symbol numbers. So here's an example of nuclear symbol, and the key to nuclear symbol is you have the symbol of the element in the middle, the chemical symbol. So in this case we're going to look at Mg, or magnesium. And if you look at magnesium on the periodic table, you'll see that it has an atomic number of 12. And that's what this first number on the left-hand side, bottom left-hand side, is representing. Now, position for all of these numbers is important. So the atomic number is always positioned on the bottom left. If it was positioned anywhere else, it would be representing something else. So we always put atomic number on the bottom left. So this number down here is always the atomic number. If you recall, the atomic number, by definition, is the number of protons. So since magnesium has a atomic number of 12, it must have 12 protons. Now looking in the top left, we have the mass number. Now this is not always the same mass number for all magnesium atoms. In this case, we have 25. If you remember, the mass number comes from protons plus neutrons. Now, since we know the mass number is 25 and we know the atomic number is 12, we can easily figure out how many neutrons there are. by subtracting these. Since this has to be the protons and neutrons, and the atomic number is only the protons, we can just take the 25 minus 12. Tells us that in this case, this magnesium has 13 neutrons. Let's move over to the right side. In the top right, we have the charge. And an easy way to figure out the charge is by taking the number of protons and subtracting the electrons. So in this case, since we have a +2 charge, we can figure out how many electrons there were. Since we know that it was protons minus electrons gave us this -2, we can say that the 12, and we know that there's 12 protons, we can say that the 12 protons minus whatever the electrons are, which I'll leave blank, equals 2 plus. Well, if I solve this algebraically, I'm going to add electrons to both sides. So then I have 2 plus the electrons gives me 12. Therefore, now I'm going to move the 2 over. So the electrons must be 12 minus 2, which means there's 10 electrons. Now, the number in the bottom right always represents the number of atoms. Now, we're not going to see a lot of this right now because we use them mainly when we're talking about compounds. Common compound you're familiar with is H2O. And that 2 is always on the bottom right of the H, which represents hydrogen. It tells you there's 2 hydrogen atoms for every 1 oxygen in water, hydrogen H2O. So let's go ahead and use this information and look at some of the problems you're going to come in contact with. We're going to call these kind of problems pen problems for proton, electron, and neutrons. And you're always going to be asked some form of either determining how many protons, electrons, and neutrons you have based off of the properties they give you, like atomic number and mass number, or doing the reverse, being given the protons, electrons, and neutrons, and then determining the element, the atomic number, the mass, the charge, that kind of thing. So let's look at this first example. We have how many pen, or how many protons, electrons, and neutrons. So we need protons, we need electrons, we need lowercase e, and neutrons. Well, if you remember protons, that's always the atomic number. So we've got 2 things that we can use to get that. First of all, they give us the symbol, which Fe right here. So I know I'm talking about iron. They also do give us the atomic number, and if I double check, you'll see that on the periodic table, iron does have an atomic number 26. And if you remember, the atomic number is always the number of protons. Therefore, the number of protons must be 26. So there's 26 protons. Now let's figure out the electrons. If they do not tell you anything about a charge, remember the charge is protons minus electrons, and if there is no mention of a charge at all, then you can assume there's no charge. So here we have no charge, and the only way you can have no charge is if the electrons and protons are the same. You have to have the same number of negatives as you do positives to get no charge. Therefore, the electrons are the same number. Remember, this is only if they do not tell you anything about a charge. If they tell you there's a charge, you're going to have to figure out the electrons, and we'll talk about that, a case like that in a little bit. Now, neutrons. Neutrons, you're going to want to look at, remember, the mass number, because the mass number tells us the number of protons and electrons. Now, in this case, I think this is a typo. It should be 56. It'll make more sense with 56. So we have a mass number of 56. And we have an atomic number of 26, and 26 is the number of protons. This 56 has to be the protons and neutrons together. Therefore, if I take the 56 and subtract that 26, that should give me the number of neutrons. 56 minus 26 is 30, so there must be 30 neutrons. So we've got 26 protons, 26 electrons, and 30 neutrons. And there's our first problem. Now, we're going to do the reverse. What is the symbol? And in this case, we're going to put down the mass number, atomic number, and the charge, including the chemical symbol. So I'm going to look. We've got 20 protons, 22 neutrons, and 18 electrons. So the number of protons automatically tells me the atomic number. So I'm going to look for the element with an atomic number of 20. So I look on the periodic table, and 20 is right here. That tells me that it is calcium, Ca. So automatically I know I've got the element Ca. And I also know we have an atomic number of 20, which goes on the bottom left. So I've got 20 down here. Now I need the mass number. Mass number always goes in the top left, and it's the protons plus the neutrons. So I'm going to do 20 plus 22, and that gives me the mass number of 42. So that's my number on the top left. So I've got my mass number and my atomic number. Now I'm going to figure out the charge. You remember, charge is protons minus electrons. And I've got 20 protons minus the 18 electrons. In this case, I've got 2 more negatives than I have positives, or 2 more positives than negatives. So I'm going to end up with a charge of plus 2, or 2 plus. So I'm going to put that there. Okay. And sometimes you'll see the charge put before the number, sometimes after. It really doesn't matter. The reason why sometimes they put it after is they want to indicate that this is an electrical charge, not a mathematical positive 2. It is an electrical positive 2, which does mean slightly different things. For what we're doing right now, we don't need the number of atoms because it's not important to this because we're only dealing with symbols. Let's do one more example. In this case, they're giving us the symbol and they want us to figure out protons, electrons, and neutrons. And so I'm going to do protons, electrons, and neutrons, and simply getting them all from the symbol again, just like we did before. So remember, protons we get from the atomic number, which is in the bottom left, which tells me it's got an atomic number of 17. So I look on the periodic table for 17 protons. Electrons. In this case, I need to look at the charge. There is a charge. So in this case, we have to remember that this charge was equal to the protons plus the electrons. And that means that -1 is equal to 17 minus whatever the electrons were. And so moving things around, I'm going to add E to both sides. And then, since this is a -1, I'm going to add 1 to both sides. So the electrons has to be 17 plus 1, since I had to flip the -1 over to this side. And that tells me there's 18 electrons. And I can double check that because I know that I have 17 positive protons, and I have a charge of -1, so I should have 1 more electron than protons. That's another way you can figure it out. So I must have 18 electrons. Now for neutrons. Remember, neutrons we're going to get using the mass number. The mass number is the number of protons plus neutrons. Therefore, the number of neutrons must be the mass number, 34, minus the number of protons, which is 17, which happens to be 17 as well. So we've got 17 protons, 18 electrons, and 17 neutrons in this symbol of 3417 Cl minus 1. And that should conclude our video about protons, neutrons, and electrons, the three main subatomic particles.